Good evening, sir.
Good evening.
Good evening, sir.
Good evening. Good evening,
Good evening,
everyone.
sir.
Okay. So, how many of you are there? Yes, Suleka Madam is there, Samir is there, Ketan, and Avinash. Okay. Uh, Let me present first so that I always forget that. So, share. Okay. Now, I have been, I'm presenting, and I think my desktop is visible to all of you. Yes.
Yes, sir.
Yeah. Okay. So, let us let us go and click on RCDC. So today we'll be going for design of slab using RCDC. Yes. Okay. So I'm opening the things. Okay, you can say residential building. Okay, then client you can say batch. The batch is 20, 21. Engineer you can say me, and this is the address where you have stored your MDB file. Okay, and where it has been stored in a tab tutorial, and let's say this is your file. Click open, so the address will be given to this, and then you can see we have checked for footing, column, and wall beams, and now we'll be going for slab. And let us today we'll go with slab number 4. So you can go with first slab, second slab, third slab, fourth, one by one. So I'm choosing fourth slab and create new project. So now it will start reading all the data regarding slab that has been stored in the analysis file, which has been stored as MDB file. You can see reading analysis model, and it is reading everything which is related to slab. Clear? Hello.
Yes, sir.
So this is how you can create your MDB file and use it, import it in RCDC. And now the same process will not change. The only thing is that the data has been changed, and you can check the data that has been given as per your choice. So actually this has been to be like this, but that we can see. So you can check that this is S2, this is S3, this is S4, etc. Okay. So you will have to go to settings. Click on settings and click on
Design parameter.
design parameter. Now, what are the parameters that you need for your design? Whether you are using curtail bar or whether you are using bent up bar. So let's say we are going to use bent up bars. Then preferred span to depth. Now again, this will be as per your IS 4 by 6. You know that for cantilever, your span by D ratio is 7, and this is basic. That is a basic span by D ratio. So simply supported will be 20 and continuous will be 26. I think all of you know this, right? Yes.
Yes, sir.
And similarly, this is for two-way. If your two-way slab is simply supported, then you are going for 28. And if it is continuous, then you are going for 32. And this is as per IS 456 clause number 24.1. So even if you do not know, you can go and see this clause number 24.1, and there you will find all this data, right?
Yes,
Then
sir.
what about material property? You can say grade of
Impurity.
concrete, that you can choose any grade of concrete over here, but we'll go for analysis. Then same for steel. Then cover, main cover for slab, again it is 20 as per our codal provision, and minimum thickness. Now here you can say any thickness as a minimum thickness. Uh,
125 generally.
Yeah, see, we are providing minimum. That doesn't mean that the software will go for only 100. So he will find it based on your either L by D ratio or your design parameters. Okay. So,
Okay, sir.
yeah, so minimum you can say anything. So, see what will happen if I provide 150 over here? What will happen? Can you imagine? See, even if in this case, even if let's say this slab, even if this slab does not need 150, he will consider 150 because you are saying that I don't want anything less than 150. Okay, so that's why either you may go for 115 or you may say 100, because in this case he will consider 100 and then find out this basic span to depth ratio, and then modified span to depth ratio. Then he will find out the depth required as per our bending moment, and then if it this is not sufficient, then he will go for higher, which will be 115, 125, till these requirements are satisfied. Clear?
Clear, sir.
Now you can see detailing options, whether you want number of rebars in one slab or you want it in terms of spacing. So if you are going for rebars, then he will ask you preferred diameter,
Minimum.
and if you are going for spacing, then he will ask you preferred spacing. Now this is a preferred spacing, so you can say that first he will as you are preferring 150, he will check whether 8 or 150 is sufficient, or if it is not sufficient, then he software will go for 10 or 150, etc. So you can choose here as minimum something as 125. Then you can see this bent up. Now when you are going for bent up bars, he will ask you what is your bent up schedule. So here you can provide as per, so bottom end support, how much we are going for bottom end support, L by 7, or you may say L by 6, is up to you. Then bottom continuous, you may go for L by 5. So this may be, normally it is L by 7 and L by 5 at continuous, and top continuous will be L by 4. So these are the normal uh, uh, supports curtailment where you are going to bend your bottom reinforcement, or where you are going to bend your top continuous support. So that is what is normally specified, or you can specify it as per your choice. Clear?
Clear, sir.
Then rebar diameter, whether 8, 10, 12. So these are the available diameters, and you can see rebar spacing. So minimum Again, you will have to see the clause regarding minimum, or you can say by your thumb rule that 100 is the minimum, and maximum, you can say you are not interested going beyond 200. So you can specify it 200 and round up by 5 mm. Okay.
Yes, sir.
And then click OK. Crack width settings. Again, this is for water retaining, or I will just show you what. So if you say that perform crack width, then he will ask you which code is to be used and permissible crack width. So you can provide what is the permissible crack width in as per your code, right?
Yes,
And
sir.
this thermal checking normally not used, but you can go for this, or you may say that you're not interested in crack checking. Then set all panels as non-continuous. What will happen? Hello. See, if I go for set all panels as non-continuous, what will happen? Yes.
The ants are not free to lift.
No, no, that is different thing. See here, when you are saying set all panels as non-continuous, that means he will consider all panels as discontinuous. Now you can say that this slab is continuous on this side, or this slab is continuous on this side, right? Or continuous on this side, or it may be continuous on this side, depending on your situation. Normally, what is the case? Normally, you can see this is your sunk, this is your sunk, this is your sunk, this is also a sunk, but these this S11 and this S9, these are at one level. So this this edge may be considered continuous, this edge may be considered continuous, but this edge will be considered discontinuous because discontinuous in this part, right?
Yes, sir.
So it is up to you. But uh, whether I want to ask whether you will consider all panels as non-continuous, or you will take the advantage of continuous. Now what is the advantage of continuous? Can anybody let me know? Yes, anybody? What will happen if I consider a slab continuous, or if I consider the same slab as discontinuous? Will it make any difference? Okay, do you see this? Hello, hello.
Yes, sir.
Yes, sir. We see.
Let's say this is your beam and this is your beam, and let's say it is not continuous on this side, it is not continuous on this side. So this slab will be considered as discontinuous on both ends, right? Yes,
Yes, sir.
that means the support will be considered as hinged. Okay, and if you see the bending moment diagram, then according to this support condition, you will have a bending moment diagram like this. That means you will have a span moment over here as max. How much? WL square by 8. Yes or no?
Yes, sir.
So this is the condition when you will consider ends as discontinuous, or let's say in this language where he is considering it as non-continuous. So discontinuous or non-continuous is one and same, right? Clear?
Yes, sir.
But here you will get moment equal to 0. Here you will get moment equal to 0 because this is a simply supported condition. Maybe about beam or maybe about slab. Clear? Now let us consider another situation. I am having a slab so this will be continuous edge and this will be discontinuous edge. That means you will get a simply support moment over here and a continuous, or it will be considered as fixed end. And in that situation, if you go for calculation of your bending moment, you will get a bending moment something like this. And because of this negative moment, you will get a reduced moment. So this moment, this M will be less than M simply supported. Let's say this is M1 and previous it was M2, right? Yes.
Yes, sir.
Yes, sir.
So in another way, I will say that I will get a economical design for this slab if I consider this end as continuous, right?
Yes, sir.
Now what will happen with this? Both ends are continuous. And then you will see that you will have a bending moment diagram, something like this. And then this will be minimum because it will be something around WL square by 12, 24, right?
Yes,
Yes,
sir.
sir.
Which is less than WL square by 8, which is for simply supported. But in that case, you will have to design a slab for this moment, which is WL square by 12. But finally, you will see that this depth is minimum. D will be minimum because bending moment is minimum. And in this case, D will be maximum because bending moment is maximum. Yes.
Yes, sir.
So now whether you want, the software is asking you whether you want to design it for this case or this case. And what will be your answer?
Continuous.
Continuous, sir.
Continuous.
But let me tell you one thing. Definitely you're going for your economical design, but let us see what happens if I say this is, let's say this is my slab thickness, right? And I'm providing a reinforcement which will be bent up over here, and it will be provided something like this, and to remain this bar at top. Now see, this bar is not 16 dia or 20 dia, so this is most of the time 8 dia or 10 dia, right? Yes or no?
Yes, sir.
So this is very flexible, and when people are walking on this, because this is not concreted, so you will have to provide some support to maintain this bar over here. And if the supports are not properly provided, this bar may bend like this. So you will not have a bar at this level, but instead it will be lesser, right? Or many times it may bend something like this. Yes,
Sir.
bars. My bar. So if I am saying that this is my bar, this is bent up and provided over here like this. Now this top bar does not remain at top, and if you see your fixed end moment diagram, you will see that you will be having a moment something like this. So if this bar is not at top, then this moment resistance will be lesser, and you will see a cracking over here. So cracking, maybe cracking over here, right?
Right, sir.
So do not go for that type of economy. Always consider them as this. Now, one more thing is there. Even most of the time, moment in the slab, MU, that has been calculated for this. So, what is the span? Maybe around 3 meter, right?
Yes,
Or
sir.
maybe around something around 4 meter. So, the span of the slab is 3 meter to say 4.5 meter. And because of that, MU is less, and depth required from this criteria may be very less than depth required with that L by 28 criteria. Yes.
Yes, sir.
So many times this depth as per calculation of MU is very less, and we have to go for depth required for this, for performing our serviceability criteria. So that means if you are providing higher depth, then a reinforcement that is required to be provided will be very less. So there is no point in going for a reduced depth, because this criteria is based on serviceability, which is depending on length of the slab, maybe 28, maybe 32, and maybe 7, whatever it is, right? Hello.
Yes, sir.
Yes, sir.
So the depth required is based on serviceability criteria, and you can check your calculations, and you will always see that depth required from bending moment criteria or strength criteria is something around, say, uh, something around 80. Then you will add cover 20 plus half the diameter of the bar, or let us say 10. So it is coming out to be how much? 110. So required from bending moment criteria, you are getting total depth as 110. And let us say that you are having the criteria, let's say you are having a span of 3000. So divided by 28, how much it will be? Yes. Let us consider this as 30. Then how much it will be? 100 plus
Yes, sir.
120.
Plus 7.
20 plus 10. Or how much it is? 130.
130.
So whether it is required from strength criteria or not, you have to provide 130 or maybe 125 for this span. And what will happen if you are having a span of 4 meter? It will be again more than this. Yes.
Yes, sir.
Yes, sir.
142.
So that's why you cannot reduce depth only based on strength criteria, because there is another criteria that you have to fulfill. Otherwise, the structure will be subjected to slabs will be subjected to excessive deflection or cracking at the bottom or cracking at top, which is detrimental. And that's why we'll be considering most of the time we'll be going for what? We'll be going for set all panels as non-continuous. Clear?
Yes, sir.
Again, I will say that never ever follow anything blindly. Now, let me tell you, whatever I have considered or whatever scenario that I have discussed was about residential buildings having low spans. But what will happen? Let's say what will happen when you are supposed to design a slab which is having a panel something like this. Let's say it is 5.5. So this is 5.5 meter and this may be 4.5 meter. And live load that you are supposed to provide on this, as it is a commercial, maybe something around 5 kilonewton. In that case, your MU will be very high. MU will be high. And in that case, you might need from depth criteria, strength criteria, or bending moment criteria, you might need depth of the slab something around 200. And from serviceability criteria, you might need it as 150. So in that case, you can go for a reduced depth, or in that case you can say that whether you can check whether this is continuous or not, because in that continuous conditions you will get reduced mu and hence you will get reduced depth, right?
Yes, sir.
So what you will do, you will check the suitability of this clause as per your conditions. So what you are going to design? Are you going to design a slab which is spanning 2 meter? Let's say it is spanning 2.5 by say 3 meter, or maybe 2.5 by 4 meter. Or you may say that you are designing this slab which is just 1.8 meter, or this slab which is just spanning something 1.2 meter. In that case, you may go for 125, even if it is not required from strength criteria. Clear?
Yes, sir.
And when you are supposed to, let's say this is the living and it is having a high intensity of live load, maybe more than 3 kilonewton or anything, because of that you need the depth of slab more than say 150. Then you can check whether you can consider this, you can consider this as a continuous or not. You can consider this as a continuous or not. So based on that, your span moment will get reduced. So depth will get reduced. Clear?
Yes, sir.
Yes, sir.
So that is why I always say that never ever follow anything blindly. Check the things, because many times situation may be different, right? हेलो.
Yes, sir.
तो एक थोड़ा सा जोक मैं आपके साथ शेयर करूंगा इस चीज में. एक आदमी था जो रोड पर जोर जोर से भाग रहा था. तो किसी दूसरे आदमी ने उसको पूछा और बोले भाग क्यों रहे. बोले दिख रहा नहीं क्या, सामने लिखा है स्पीड लिमिट 20 किलोमीटर पर आवर. But that board is for vehicles, not for people who are crossing or who are having are pedestrians, right?
Yes, sir.
So the rules that I am specifying are applied to various conditions, right? So you have to check which condition that you have to fulfill. Whether your strength criteria is providing you more depth, or whether your serviceability criteria is asking you more depth, and based on that, you can go for to conditions. Design the slab. Definitely, this slab is continuous on this side and this side. That is okay. But if you are going for proper design, you will get safe, economical, and workable solution. Clear?
Clear, sir.
Sir.
So never ever say that I am going to consider continuity or I am not going to consider continuity. You will say that, sir, it will depend on the other parameters. What is the load? What is the size? And whether I will be benefited by considering continuity, or I will be benefited by not considering continuity. Clear?
Clear, sir.
Yeah. Now you can see the things have been done in all respect, and you can go for auto design and check
Yeah.
why these things are coming, because here live load is not considered. Why, I don't know. You will have to consider some wire. So this is a slab, so you have to consider live load as 2, then live load as 2, then this live load as 2, 2. I think it is not read, or we are not providing that. So that you have to check in your MDB file. And then again, auto design. So आपका डिजाइन हो गया.
Yes, sir.
अब क्या है? Reports, right? So go to reports, go to stack schedule. So you can check the schedule. You can see that all your S1, S2, S10, S11, 12, 13, 21, 22, that you can see in your RCDC file, which is giving you 125. It is one way. It is having TOR 8 at 200. That is what maximum you have asked. अगर यहाँ पे आपने 150 दिया होता तो it would have given you TOR 8 at 150. And that is about short span. And you can see distribution, TOR 8 at 200 and remarks. So this is about two-way. You can see TOR 8 at 200, TOR 8 at 200, and TOR 8 at 200. And why you are getting all these? Because you are having a smaller span with smaller live load intensity and a lesser depth. So This is all what you can do with slab. Now just go for general arrangement, and in that general arrangement you can see beams legend, or you can see this is your AutoCAD drawing. Then in reports, uh, see whatever that you are getting here as a in text format, the same you can get in turn detailing. So just you can see how it is giving you that. See how it has given you. So this is one bent up bar. So this is the bottom and it has been bent and provided at top. Then this is the bottom. It has bent and provided at top and continued in another slab. So this is about one way. So this is the arrangement. You can see that. So this is the bottom reinforcement has been bent and provided on the top. So on this side it is L by 4. On this side it has been curtailed at you can check that it is 530, right? So you can get the general arrangement like this. So bent up schedule. So this will give you the arrangement of reinforcement in your slab. Clear?
Clear, sir.
Then you can go and see slab sections. If you want a slab section, number of slabs, what is the, let's say number of slab 2, then slab mark, you can say S1 and draw. You have to check it there. So this is LX and LY, then left support. You have to find this actually. Actually, you have to check it over here so that you will get the things. Accordingly, you can find this slab section, and let us go for design summary. You can check the design summary for all slabs. See here, you will get for slab number S1, your LY and LX. Then live load is 3 kilonewton, imposed load is 4.5 kilonewton, thickness is 125, span type is one way, and design code is this. And based on that, panel type is 1. You will get bottom reinforcement Tor at 200 and distribution Tor at 200. So this is all about your summary for every slab, and all the slabs you will get it something like this, whether it is two way, one way, that will be mentioned. And now if you want calculations, let's say you want to check the calculation for S1, or let's say we'll go for S1, S2, S3. Say this is a calculation for S1. Again, you can go through all this. Now this slab is S1, everything in detail has been given. So the live load, slab thickness, based on that, effective depth along LX, D effective is 100. Then self weight is calculated, total load is calculated, span is there, and end condition is simply supported. And based on that, you can see design moment calculation. So this is your moment, bending moment coefficient into M. So you can check it. This TL, you can see that total load multiplied by M, which is your moment coefficient, and This is 125, then based on that 3.9. So this is your moment that for which you are going to design, and mu will be, so this is working, and mu will be 1.5 times that, so 5.96. And area of reinforcement, now this area of reinforcement is calculated by a simple formula that you might be knowing. Mu equal to Ru into BD square,
BD square.
and where Ru equal to how much? That depends on grade of concrete, whatever.
Grade of
Hmm. So point, I think it is something as point 133
1 3 for FE for,
K into BD square, right? So 133 FCK into I think that is something XU minus that all you can check that FCK BD, I think
no sir, only 0.133 FCK.
that is RU, and then MU,
Yes sir.
and based
MU
on that,
BD square.
yeah, and based on that you find D equal to square root of MU upon RU into B, right? And in this case for slab, B is equal to 1000.
Yes sir.
So this is the depth required, and then yeah, you find AST also. AST is calculated something. The formula is something 0.5 FCK over Fy into something as 1
1 minus
minus
root of 1
root of
minus
1
4.6
minus 4.6 mu upon
upon FCK
Ru,
BD.
mu upon FCK BD square,
Yes sir.
and inside outside bracket again it
Into
is
BD.
B into D. So
Yes
these
sir.
are the formulas which based on that you will see that area of reinforcement required and reinforcement provided will be calculated. So all that you can check and you get it over here. And now this is the shear check. You can see how the shear check is calculated, that tau c is calculated, and most of the time this is not required in slab, because see uh, why you don't need a shear to be checked in slab. You can uh, you can see if I draw a slab something like this. So slab is always considered as 1 meter wide strip.
Yes sir.
So if this is the span for which I am going to find out the moment, and you will see that this is the B, which is equal to 1000, and this is your D. So this is total D. Now you can see a large area of concrete, right? So if I see the bending moment, and if I find out a section over here, I will get a area of concrete which is very large. So the tau c that is of this concrete is always less than tau d. Yes,
Yes, sir.
most of the time. And now this is not the case in beams, because in beams we get a cross section something like this. So if I compare the cross section of slab and cross section of beam, so that's why I have to design the beam for this VU design. But I don't have to design or check the slab for VU. Clear?
Clear, sir.
Yeah. But even if you want to see, even if then you want to see what is the shear resistance that the slab section is providing, you can check it over here. So K times tau C, you are getting 0.138 and a nominal shear stress, and this is the shear to be uh, which is 138, and you can see the VU which is equal to 13.786, and if you see that divided by B and D, you will get very less, and that's why K times tau C will be always more than this 138, because this K itself is 1.3. Hello. See, if you see K and tau C, so tau C for any grade of concrete, let's say M20, maybe something around 0.25, I think, 25 Newton per mm square. And this K is for slabs, because for slabs you are having depth less, so you get K something 1.3, right? So this 138 will be always this K time tau C will be always greater than this. So the slab is safe in shear. Clear? You can go through the books so that you will understand what is this shear coefficient, then shear force into shear coefficient into Lx. So this is a shear that is to be uh, uh, this is the shear to be that is supposed to be acting on the slab, and based on that 1.5 times this, so 13.788 786 divided by tau v, which is the nominal shear stress. Now you are getting 0.138. Then this is the shear stress tau c, which is 0.305, and modification factor, see here 1.3, and modification factor K dash, now it is coming out to be 0.396, which is always greater than 0.13. So 0.1 is always greater than, I mean 0.4 is always greater than 0.1. Yes?
Yes, sir.
Okay. So that's why normally the shear check for slab is not carried out practically, but if somebody wants, he can. And this is very important, deflection check. So Lx by D, that has to be uh, less than your allowable deflection. Yes, and you can go for this. So basic span to depth ratio is 20, then correction factor, which is 1, then tensile steel factor, which is 2.64, then compression steel factor is, as there is no compression steel, so factor is 1, and flange correction factor, again, it is not a flange, so it is a rectangular. So finally, you can see maximum span to depth ratio, which is uh, You can check alpha 1, alpha 2, alpha 3. So all that is coming out to be 52, and allowable, you can find out LX by D, which is 17.3, which is always less than this. So this is maximum span to depth ratio allowable, and this is actual. So actual L by D is less than allowable. So now allowable L by D you are getting 52.8, and actual you are getting only 17, and then the deflection check is satisfied. Similarly, for other slab, you can just go through that and you can find it entire reinforcement. So that is also there. And let me see this bill of quantities. Actually, I'm not using it. So plan area, so bill of quantity summary. And you can ask. You can see this with your help file, because normally I don't go into that, because yeah, it is showing you the bill of quantities for different uh, uh, what I will say that uh, element slab 1, 2, 3 units and total consumption, etc. You can check that. That is not a big issue. Okay, have you got through the designing a slab? Actually, one does not need for that, but I don't know why we go for that. Yes, any query? Yes, anybody having any query?
No, sir.
Any doubt about how you're going to design the slabs, or what is the process? See, there are only two things. If you are having a slab something like this, so you can call this as LX, this as LY, and depending upon a span LY by LX, whether it is if it is greater than 2, then it is one way. Yes, and if it is less than 2, then it is two way. Is it
Two-way.
correct? Hello. So whatever I am
Yes, sir.
saying, is it correct or not? Yes.
Yes.
Hello. Yes. Anybody who does not agree with my statement that if this Ly by Lx, or let's say alpha, which is aspect ratio, if it is greater than 2, then it will be designed as one way, and if this alpha is less than 2, then it will be designed at two way. Yes.
Yes, sir.
All of you agree with this or not?
Yes, sir.
Hello.
Yes, sir.
Everybody agree? Yes or no? Agar yes say, तो you can say yes. If you are not agree with that, whatever comment I have made right now, you may say no. Yes.
Yes, sir.
Yes, sir.
Everybody agree? Again,
No, sir.
why?
Sir, longer span by shorter.
Yes.
The
Hello.
longer span.
Ly by Lx, which is called aspect ratio alpha, if this is less than 2, then it is called a two-way slab.
Yes, sir.
And if it is greater than 2, then it is called one-way slab.
One-way slab.
One way slab.
Yes or no?
Yes, sir.
Yes, sir.
Everybody? Then all of you are wrong. All of you are wrong because I have not said anything about support conditions. You should ask me, but sir, what is the support condition? Let's see. This is your slab, and this slab is supported on this side,
Longer span.
and this is supported on this side. Then whatever may be the aspect ratio, whether it is less than 2 or whether it is greater than 2, it is going to span like this, because this is a pre-end. You cannot transfer you cannot transfer load on pre-end. Yes. Are you getting it? Now let us
Yes,
say
sir.
that, see, this is your slab, and it is supported on this end, and it is supported on this end. Then it will be whatever may be your aspect ratio, it will span like this, because this is pre-end. Pre-end कभी support देता है?
No, sir.
Yes. So that means whatever statement I was making before was 50%. I was not giving you any information about end conditions. What are end conditions? Now you have assumed, see, I don't know why, but every one of you have assumed that I was talking about a slab which is supported on all sides. A slab which is supported on all sides, whether it is a continuous support or whether it is a discontinuous support, that is different thing. Now, if this is the case, the slab is supported on all four sides, then it will behave as a one-way or two-way, depending on your aspect ratio, whether it is more than 2 or less than 2. So the first you have to find out the support conditions, and then you will check the aspect ratio, not before that. Yes.
Yes, sir.
So just think
Yes, sir.
that you are having a slab, something like this, and it is supported on one edge only. Will it act as a one-way or two-way? It will act as a cantilever. Right? It will act as a cantilever. So whenever you are checking or you are deciding whether your slab is one way or two way, first check the supports and then check the aspect ratio. Your first check should be end condition, and second check should be aspect ratio, and then you can
check कैसे
decide
करेंगे?
whether it is one. Clear? हेलो,
सर इसको चेक कैसे करेंगे?
क्या?
इन कंडीशन
अरे
और
बीम है कि
अल्फा?
नहीं?
हाँ।
सी सी दिस इज योर स्लैब. अगर
यस
यहाँ
सर।
पे बीम है, यहाँ पे बीम है, यहाँ पे बीम है, और यहाँ पे बीम है,
यस सर।
then it is supported on all four sides.
यस सर।
अगर अगर यहाँ पे बीम नहीं है, then it is supported on three sides.
3 साइड।
अगर यहाँ पे बीम नहीं है, then it is supported on opposite ends. अगर यहाँ पे भी बीम नहीं है, then it is supported only on this side. Clear?
ओके सर। यस सर, क्लियर।
So you have to see whether the slab is having a support on whether the slab is supported on beams or not. See whether it is continuous or discontinuous, that is different thing. But first you have to find out whether it is supported or not. Right? And after finding your end conditions, only then you are going to calculate your alpha and check that whether it is less than 2, then two-way, greater than 2, then one-way. But if you are not having end conditions on all four sides, then this is of no use. Right? See, this is the always a question that is tricky question asked in your interviews, and I have seen 99% students. I don't say that they don't know it. The only thing is that they are very, very uh, uh, enthusiastic on answering, or they want to show that they know it. And that's why they go on saying that, sir, when alpha is, that aspect ratio is less than 2, it will be two-way, and aspect ratio is more than 2, then it will be one-way. But don't forget whether the beams are surrounded on all four sides. If the beams are not surrounded, then calculation of aspect ratio is of no use. Clear?
Yes, sir.
So there are situations many times. Actually, that situation is not over here, but there are situations in many times that you don't have a support on longer side. You have a support on short side. In that case, this slab, whatever may be the aspect ratio, this slab is going to bend like this. Yes, that means a spanning will be like this. So even if this is 5 meter and this is 2 meter, and you will find out 5 by 2 is greater than 2, that means it is one way, and you will say that one way is like this. It's not the case. Slab will be spanned on the supports. Now, if this is a free end, this is a free end, how this free end will provide a support? It will not provide a support. बराबर है? हेलो,
Yes, sir.
देखिए try to imagine that you're on a surface something like this, and you're here, you're somewhere here, and if some person is going coming towards you with a gun, and he's trying to shoot you, you will start running in this way. But at this way, will you jump down because of the fear of this person who is trying to shoot you? Yes. ऐसा होगा
No.
क्या? हेलो,
No.
No,
नहीं
sir.
होगा ना? तो इस केस में the load is not going on this side because this side is like this. This side is also like this. So the load will try to follow the safe path. Clear? जहां सपोर्ट है वहां ही आप जाओगे ना.
Yes, sir.
That is the law of
Yes,
nature.
sir.
So that is the law of nature. So don't forget this basic funda, because most of the time we are interested in finding out the formulas, aspect ratio Ly by Lx, Ly by Lx, and we forget that Ly by Lx is assuming that slab is supported on all four sides. That is a hidden assumption in calculation of Ly by Lx. So don't go blindly. First find out whether there are supports, and then you can go and find out the aspect ratio. Clear?
Yes, sir.
Tricky है ना?
थोड़ा सा ध्यान देना पड़ेगा सर.
हाँ, तो इंटरव्यू में ऐसा ही होता है. इंटरव्यू में क्या होता है, वो हमें ऐसा लगता है कि बहुत आसान क्वेश्चन पूछा है यार. Ly by Lx less than 2 2 way, greater than 2 1 way. We forget the catch. And the catch is that you are not inspecting the support conditions. Okay. Any other query? If you can ask me. Otherwise, we'll conclude today's session. Hello.
सर एक पूछना था. स्टार्टिंग में हमने स्लैब का जो डेटा इनपुट दे रहे थे,
हाँ.
उस समय हमने वो बेंट अप लोकेशन पुटअप किया.
Which one?
बेंट अप लोकेशन.
हाँ.
सर वो मींस आईएस कोड के हिसाब से होता है या वो?
ये
यस सर, दैट बेंट अप लोकेशन.
ये location.
यस सर.
See, that is usually that has been actually defined in the code, but you can see if this is your simply supported slab. Okay, right? Hello.
Yes sir.
Now you are finding a bending moment like this, and let us check the moment at this location, or let us check a moment at this location. Let us say this moment, I will call it as MU, which is at center of span, no? Hello.
Yes sir.
And what will be the bending moment at this? Will be something around MU by 2. Are you getting it?
Yes sir.
And this location is something around L by say 10, or let's say 6. So this portion of the slab is not subjected to this maximum moment. That's why we can curtail the bars. We are saying that now here all bars are not required, so we will be curtailing 50%.
Yes sir. Alternate करना.
Right?
Yes sir.
So this is about simply supported. Same you can say about continuous support. So here you will say that actually here there is no moment at the bottom. The moment is at the top. Here there is no moment at the bottom. The moment is at the top. So you can say that you are providing a reinforcement something like this. and this is my support, this support. So I don't need, theoretically, I don't need any reinforcement over here. So 50%, even then I'm providing 50% over here at bottom. And remaining 50% I am providing over here to take care of this moment. Got it?
Yes, sir.
So that is that portion, L by 4, L by 6. You can find out with the help of bending moment diagram, normal bending moment diagram. See, if this is your span and you don't have a bending moment something like this. So the bending moment goes on increasing as you go towards the span, and it goes on reducing as you go towards the support. It is not a constant like this. Yes.
Yes, sir.
See what we do in steel structures. In steel structures, we can have additional plates over and above this I section. So this is your I section. This is your flange. This is your flange. And if you see from this side, you see something like this. And additional flanges are provided at top and bottom, these. And in this portion, you don't need any additional flange. The same concept, bending moment diagram. As you go towards support, the moment goes on reducing. And if you analyze the structure, then you will get actual things. What will be here, it might be something 13 kilonewton meter. And at this location, you might get something around 7.5. So you need lesser reinforcement to resist this than this. Yes, this is the common sense. So I will say that you can have one general rule that you will provide reinforcement wherever you need, you are having bending moment. Clear?
Yes, sir.
So if I say this is my continuous beam, or let's say orang. So this is my cantilever part, this is my cantilever part, and these are the two supports. Then I get a bending moment diagram, something like this. You can say. So this is not like that. I get a bending moment diagram, something like this. Right. So here it is 0. Here it is 0. Here it is max support. Here it is max. Then here it is a contraflexure. That means point of 0 bending moment. Here it is point of 0. So only in this part, theoretically, I need a reinforcement to be provided at bottom. Right. And only in this part, I need a reinforcement to be provided at top. I need a reinforcement to be provided at top. And for that LD point of view, you can say that whatever is this part, whatever is this support, you are providing reinforcement, backward anchorage on this. Clear? Yes.
Yes, sir.
See, many times I ask people why we are finding bending moment. Just we don't have any work to do. Why we are interested in finding shear force? Why we are interested in finding bending moment? Because they provide us some information where we should provide a reinforcement, how we should provide a reinforcement, and what amount of reinforcement is required so that that portion will not get cracked. The same way, the shear force will give us the indication where I should provide stirrups, clothes, what should be the spacing, and where I theoretically I don't need to provide a stirrup, right? नहीं तो बेंडिंग मोमेंट और shear force निकालने का कोई जरूरत ही नहीं है ना, बराबर ना?
Yes, sir.
So always design is always based on your analysis. Why we go for calculation of reactions? Because that reactions and they will give us information about internal stresses that could develop in the cross section, and we have to say that there has to be some something that will absorb that resistance, right? So just go through that very common thing. जहां पे क्रैकिंग है वहां पे आपको reinforcement प्रोवाइड करना पड़ेगा. जहां पे क्रशिंग है that will be taken care by the concrete. और कितना लेंगे वो उनके ताकत से बाहर तो नहीं लेंगे ना. So we have to see that the concrete has sufficient strength so that it can take the crushing that is subjected due to the external loading. Similarly, a reinforcement will take care of any strength or any stress or cracking that could be that external forces will create. Clear?
Yes, sir.
So that is a simple thing, and the entire codal provisions are based on that. You can correlate with the drawings, and you can see why the code is asking you for certain a minimum depth, certain minimum reinforcement, certain maximum reinforcement. It's all based on stress that the material is subjected. क्योंकि हम बोलते हैं ना, हिसाब से ज्यादा स्ट्रेस हुआ तो फेलियर होता है. यस.
Yes, sir.
हार्ट अटैक से क्या प्रॉब्लम होता है? द हार्ट कैनॉट सस्टेन दैट प्रेशर दैट द वेन्स आर developed, or the internal system has developed the pressure on the veins, and then we feel that massive attack, right? So same thing, the things are applied in structure. Okay, any other query? Yeah. So shall I conclude today's session? Hello.
Yes, sir.
Yeah.
Yes, sir.
Okay. I hope that you people are enjoying the sessions, and you're working on exercise.
Yes, sir.
या जितने एक्सरसाइज करोगे उतना सबके लिए अच्छा है. और आने दो ना, डिफिकल्टीज आने दो. डिफिकल्टी सॉल्व करने के लिए हम लोग बैठे ना. बट कम विद द डिफिकल्टीज. यस अविनाश, कुछ पूछना
Yes,
चाहते
sir.
हो? पूछना चाहते हो?
नो सर, एक्चुअली नहीं सर, कुछ भी नहीं.
तो फिर ज्यादा स्टडी करो सो दैट पूछ सके.
ओके सर.
Okay. Okay, then with this, we'll conclude today's session. And I think next time we'll go for some, I think that about SAFE, how to design footings with the help of another software called SAFE. But I don't know. I will have to talk to Anil sir, because your some basic sessions are still left, and he will address all those.
सर एक
Otherwise,
प्रोजेक्ट
yeah,
एक फुल प्रोजेक्ट
yes.
करते हैं तो आप एक कोई भी एक फुल प्रोजेक्ट करते हैं उस पर सारा चीज तो थोड़ा और क्लियर हो जाता लाइव
तो
प्रोजेक्ट
लिखने वाले हैं ना हम लोग, बात खत्म थोड़ी हुई, एक एक मॉडल हो रहे हैं।
हाँ वो तो है सर, लेकिन एक अभी कर दे।
नहीं आप करो, मैं वही तो आप लोगों से हमेशा कहता हूँ कि यू गो अहेड विथ सम प्रोजेक्ट एंड वेयर यू विल स्टक अप विल ट्राई टू हेल्प यू।
ओके
या और वैसे भी one entire project will be going through that. I will be explaining that I think that is 18 story structure. उससे तो बड़ा प्रोजेक्ट नहीं लगेगा ना आपको।
नहीं सर,
18 माले का बिल्डिंग हम लोग मॉडल देखने वाले हैं, उसका आर्किटेक्चर ड्राइंग देखने वाले हैं, उसका डिटेल ड्राइंग देखने वाले हैं, उसका आरसीसी ड्राइंग कैसे डेवलप किया उसके बारे में बात करने वाले हैं, और फाइनली रिजल्ट्स भी देखने वाले।
ओके सर।
या okay, then with this we'll conclude today's session, and let us meet day after tomorrow. Either me or Anil sir will carry out the sessions.
Okay sir.
Okay.
Yes, sir.
Yeah.
Thank you, sir.
Thank you.
Thank you, sir. Good night, sir.
Thank you.
Thank you, sir. Good night, sir.
Yes.